Now I haven't done any differentiating yet, that's just the function in a different form. But now that I've got it in that form, the derivative is a piece of cake, because we just used the power rule. Okay, so derivative of 2x cubed, 6x squared, plus the derivative of 5x squared, 10x. The derivative of 3x is 3. And then we're supposed to substitute a negative 2. So f prime of negative 2 is equal to 6 times negative 2 squared plus 10 times negative 2 minus 3. Which, that ends up being doing a little bit of arithmetic. Number 1. Okay. Notice, none of this stuff involved using a calculator. And I want you guys to try to resist the temptation to use a calculator on basic arithmetic. And it might be a little bit hard at first, but you guys need to develop proficiency of doing math in your head, because half of the AP exam is no calculator. And so, you know, it might take a little bit of time to get used to that, because we're so used to reaching for the calculator when you have to do 2 times 3, which is a little pathetic. But you know, some of you do it. And you got to get out of that habit. And the only way is to force yourself to just think about it. And the more you do it, the faster it'll end up coming to you. You guys are all smart people. So, well, all but, you know, a couple of you. Just kidding. And so, you know, your brain will kind of retrain itself to think on its own and not rely on the calculator so much. All right, now you guys do this example. Here's the function. And what I want you to do is to find the f prime at 3. Okay? So simplify this by distributing the x. Use the power rule to find the derivative. Plug in 3 to find the derivative at 3. So if you can pause the tape or pause the DVD player for about 2-3 minutes and let the students work on this. I'll be back with the answer in a second after this commercial message. All right, I'm back. Hopefully you got the answer to the problem. So I'm just going to go through this really quick, just to check your work. So if I rewrite the function by distributing the x, I get 3x cubed plus 2x squared minus 7x. The derivative, using the power rule, 9x squared plus 4x minus 7. Then we substitute a 3. So it's 9 times 3 squared plus 4 times 3 minus 7. And yeah, that's arithmetic you can do without a calculator. 3 squared is 9 times 9 is 81. Plus 12 minus 7. 81 plus 12, that's 93. Or you can do the 12 minus 7 first, which is 5. Add it to 81, 86. Okay. So there's your answer. Hopefully I did that right. Usually I rely on you guys to tell me when I make a mistake. So since you're not here, you'll just have to forgive me if I make a mistake, because it happens to the best of us. It really does. Okay, another thing you're going to be asked to do, and this is a typical AP question, not only are they going to ask you to do simple things like that, but they will give you other questions that essentially make you do the same work, but kind of twist the words and make it a little bit confusing. So here's an example of a problem that you would see on the AP exam. They would say, does the function f of x equal x cubed minus 2.5x squared minus 2x plus 8 have any horizontal tangents? And if so, where? Now this is not a yes or no question. You just don't say yes and then you go on to the next question. You have to actually think about it. But notice there's no mention of the word derivative. They don't say find the derivative and do this to it. They're asking you a question that is assuming that you understand that we're dealing with tangent lines, and tangent lines are related to derivatives because derivatives are the slope of the tangent lines. Horizontal tangents means that the tangent line is flat, thus has a slope of 0. So what we're looking for here is to figure out where, for what x values, is the derivative 0. Okay, so you have to translate it into a derivative problem. So the problem is actually pretty easy. We're going to take the derivative of the function using the power rules, 3x squared minus 5x minus 2. And we want to find out where is that slope equal to 0. And this turns, after we've done the derivative, it just turns into a quadratic. So we're going to factor this. And this factors as x minus 2 times 3x plus 1, which if you set each part equal to 0, that gives us the answer x equals 2 for that factor, and x equals negative 1/3 for that factor. So those are the two x values for which the tangent line is horizontal. Okay. Now I'm going to actually show you the graph of this function, so I can make a graphical connection between the algebra and what's actually going on in terms of slope. Okay. So let's take a look at this function. Type it in here. Hey, Blaine, pay attention back there. Wake up. Get off your BlackBerry. Stop texting. Pay attention. Come on. All right, so there's the function. I'll just do a quick zoom 6. So here's what the function looks like. Now notice the two values at which we had horizontal tangents. The first answer was negative 1/3. Negative 1/3 is right here. So notice that as you kind of come around, at one point the slope goes horizontal. Okay? And that's going to happen anytime we have a maximum point. The slope is going to instantaneously go to 0 at the peak. And then the other point we found there's a horizontal tangent was at 2. So you can see in the function it's coming down, it goes flat instantaneously right here at the minimum. Okay? So we talked about this when we sketched derivative graphs. Whenever you have a peak or a valley, the derivative there is 0, which means you have a horizontal tangent. Okay? All right, back to our work here. The next very important rule we need to talk about is the product rule. And earlier I alluded to the fact that finding derivatives of one function times another is not just as easy as finding the derivative of one function times the derivative of the other. Okay, it doesn't work that way. And I'm going to show you with an illustration. Now this is an oversimplified example just to prove the point. We wouldn't actually do the derivative this way, but I'm trying to illustrate how this rule works. So let's say we have these two functions. Again, very simple power functions. 3x to the 5th and 2x cubed. Now let's say we want to find out what is the derivative of the product of the two functions. What's the derivative of f of x times g of x? Okay, what's the answer to that? Well, someone might think, all we have to do is take the derivative of this, which is 15x to the 4th, and then multiply it by the derivative of this, which is 6x squared. And that's how it worked with the sum and differences. Well, if I multiply those together, 15 times 6 is 90. X to the 4th times x squared is x to the 6th. So I wonder if 90x to the 6th is the derivative of the product of the two functions. Well, because these two functions are so easy to just multiply together, we can check that result. Okay? So f of x times g of x, it's just 3x to the 5th times 2x cubed, which is 6 times x to the 8th. Okay, that's this function times this one. Now, if that is